Welcome. In the third lecture of projection of solid. Now, this is question. As you remember, we see last time the two basic positions of projection of solid. That is axis perpendicular to HP and axis perpendicular to VP. Okay. Now, today we see the third position, means next position of projection of solid. So I continue from this position only and explain you that how we start from this position and complete the next position. So first I write here third position. So what is our third position? This is our third position. Third position. Axis inclined to HP and parallel to V. This is our third position. Axis inclined to HP and parallel to VP. Now see here. Axis inclined to HP and parallel to VP. And you know that in the position of straight lines, one parallelness is compulsory or important to start the question, because first we have to draw a true, either true length or true shape or true base like this. So first we assume that this is perpendicular. First we assume that this is perpendicular. And our first initial position is perpendicular to HP and parallel to VP, or perpendicular to HP, as we have drawn last time. So this same position we draw first. This is axis perpendicular to HP. We take first problem of pyramid and next we will take second problem, that is of prism. So this is the basic position first. If you remember last time I told you that these are two basic positions, perpendicular to HP and second is perpendicular to VP. And every problem should start from this position. So if our axis is inclined to HP and parallel to VP, first we assume that it is perpendicular to HP and we draw the perpendicular to HP position. This is a square pyramid, as you know, last time we have drawn it. So this is square pyramid, axis perpendicular to HP. Now we further move in second step. Now see here how we incline this position. See, this is axis perpendicular to HP. And we have to draw axis inclined to HP. So we have drawn here axis inclined to HP. Suppose first I have drawn the axis. Suppose this is the axis. This is the axis. And we take a random data. Assume, suppose our theta is equal to suppose 45 degree. Suppose. So this is our axis. Now how we draw this solid about this axis exactly such that it tilt like this. So when it tilt like this corner is on xy like this. This is the length of axis. We mark length of axis now here and join here. So this gives us the position inclined to HP. But how we draw? In this process, it is not easy to draw. So we take another process. Now see here how we draw this position. If you see, this is the base of pyramid and this is the axis. So if the axis inclination is 45 degree, now what is the inclination of this base? This is 90, so this is 45 degree. Means the inclination of base is 90 minus theta, whatever given in the question. Inclination of HP. So inclination of HP, we minus from 90 degree. That angle is inclination of base. So from this point we start. Now how? See here. From this point we start. So we incline this base 90 minus theta. So that is, if we assume the angle is 45 degree, so 90 minus 45 is again 45. So we incline this base 45 degree. So we draw here 45 degree. This is the angle 45 degree. No need to write here because we showing angle on at the position of axis. So now take this or this, means the position of this axis. We have to draw position of axis. So simply by compass we take this length and mark here. So this gives us the position of axis. Now draw a perpendicular line. This gives us the position of axis. So you have right here, theta is equal to 45 degree. This is the position of axis. Now the same length we mark here. So we get the another point of base. Now the length of axis or height of axis is given. So from this point we mark length of axis. This is our point O1 dash. Now join. Okay, we mark these points first. This is A and B. So this point is our A1 dash and B1 dash. And this point is our C1 dash and D1 dash. Now join O1 dash to A1 dash B1 dash and O dash to C dash and C1 dash and D1 dash. So this is the inclined position of this pyramid. Axis is inclined to HP. Now see here, axis is inclined to HP. Now on the basis of this, we have to draw here, that is top view. Now project all points below XY. Project all points below XY and draw the locus from base or the last top view. Then one more locus, that is from O. So draw this locus from O also. Now see what will be the intersection points. This is A1 and B1 dash, and this is A. So this gives you point A1 and this gives you point B1. This gives you point C and D, C1, and this point is D1. This point is D1, and this is O lastly, and this is O. So this point is O1. Okay. Now we have to complete this top view. Now how? Now see here. First of all, we mark an arrow here. What is this arrow? This arrow represents the direction of process or direction of observer. So if we observe from top, see, is the base visible or not? The position of base is like this. Means if we observe from top, the base is not visible. So if base is not visible, then what we have to do? Then we have to complete outer lines, because outer lines are always visible in any solid. So we complete outer line. See, this is the outer line. This is outer line. This is outer line. This is outer line. And this is outer line. This is outer line. So this is the outer line. Okay, I dark here. Now this is our top view. So we can dark it. So first we have to draw outer lines, because base is not visible. If base would be visible, then we think to draw base. Now see, the base is invisible, means the three edges of base are visible because these are outer lines, and only this edge is invisible. So we have to draw or show this edge by using hidden lines. As you know the application of hidden lines. So this is hidden. See, this is hidden line. Now we complete the solid. Now how we complete the solid? See, there are four slanting edges in this pyramid. See here, one slanting edge is OA, second slanting edge is OB, and like this OC and OD. So complete here. See here, OC and OD is only shown on drawing by completing the outlines. But A and B, we have to join it. Now how we join it? See, the base is visible. If the base is invisible, then these edges are visible, obviously. And if this is visible, then these edges will be invisible. So we draw complete lines. This is a slanting edge OA, and this is a slanting edge OB. Okay. So we can write here top view. So this is our top view. Now this is complete projection when axis inclined to HP and parallel to VP. Okay.